All right, guys, welcome to the video notes for chapter Unit 7. This is solving polynomials by factoring. So basically the whole Unit 7 on its own is basically taking a lot of the stuff we took in like Unit 2, like solving quadratics and like solving quadratic functions, and then essentially basically taking that and solving like larger degree equations and functions and all that kind of stuff. So instead of like, equations where it's like x squared or blah, 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 we'll deal with some equations that are like x cubed, x to the fourth power, maybe an x to the fifth power. Maybe not some above that, but all that, and basically like the whole unit deals with, solving, which is a lot of the first kind of few units, and then also start graphing towards the end. So basically right now what we're doing, we're starting off with section 7.1, which is solving by factoring, which is something we've already done before. So we have we have already, solved by factoring before. We factored, we know how to solve by grouping, we know how to do three terms. They say slide and divide here. I like saying, solving with trinomials, which then I kind of use the little x thing there, which I'll show you in a second. Three terms, sum or difference of cubes. Sometimes you also might have a difference of squares too, if you can break it down, but most of what we're going to be dealing with are going to be with two terms, are either going to be, sum or difference of cubes, which we have kind of right here. And then and then again, just like we did with quadratics, when we solve, we just set each factor equal to 0, and then basically solve each individual equation for x. So let's just go ahead and do a couple examples here. So I got this first example. I got 2x to the third power plus x squared minus 8x minus 4, and all that equal to 0. And I want to solve this by factoring. Okay, so how can I do that? Well, let's just go ahead and, I have four terms here, and I want to solve and if I have four terms, 1, 2, 3, 4, what I can do is I can go ahead and group them together, see if I could factor by grouping, okay? So let's go ahead and start. So let's do this. And again, when I'm factoring by grouping, I take a look at this parenthesis, I see what GCF I can take out of that. If I look at this, 2x cubed plus x squared, I can take an x squared out. And then I'm left with 2x plus 1 in there. And then for this negative 8x minus 4, I take a look at what a GCF that I can take out of this parenthesis here. And if I look, I can take out a negative 4. And if I look, I am left with, let's see, negative 8 divided by negative 4 is 2. The x stays the same. Negative 4 divided by negative 4 is a positive 1. So it turns to plus 1. All right. And this is what I'm looking for. I want to have the same exact things in the parentheses here and here. All right. And if I don't have the same things in the parentheses, then I can't continue any further. All right. There's nothing more I can do. But since I do, now I can group the outside terms right here, x squared minus 4, into its own parenthesis here, and then times another parenthesis with the 2x plus 1 right here, all right? Basically, they take whatever's inside the parentheses here that's shared, take it in here. I kind of say that's like on the inside, and then right here, outside, just kind of write out. Right there, all right? So from there, what we want to do, finding all zeros by factoring, what we want to do is we want to now, since we've factored all the way, well, we technically can do the x squared minus 4, but we can also solve that as well. Let's just go ahead and set all these equal to 0, all right? So what we're going to do, we're going to bring it over here. We're going to set x squared minus 4 equal to 0, and then we're going to do 2x plus 1 equal to 0, all right? And then if we solve this one, again, we just add the 4 to both sides, we get x squared equals 4. Square root both sides, you get x is equal to not just positive 2, but plus and minus 2. Right? Plus and minus 2 right there. All right. And then subtract the 1, you get yourself 2x equals negative 1. divide on 2 on both sides, and then you get x equals not just, so you get, and then with the -1 right there, it just turns into -1 over 2, all right? Now, because of this one up here, since we're square rooting, square root gives us, remember, square root gives us plus and minus, all right? Make sure you remember that anytime you're taking the square root. Now, for this one, well, we're not really square rooting. We're just dividing the x on both sides. We just got the -1/2, all right? Now, if we look and if we actually count here, we see that right here, this is actually the same as having x equals 2 and x equals -2. And then this is the same as x, and then, still x equals -1/2. If I look, I have 1, 2, 3 answers to my solutions, all right? So it's 3 answers to my function. And if I look at my degree here, the highest exponent, I have a degree of 3, all right? So if that's so, that is not a coincidence, all right? The degree almost, I'm going to say almost, but the degree of your function equals, and I say almost equals, the number of answers, number of solutions. All right? Now, I say almost because it's not always going to be that. Sometimes, but a lot of the times of the functions we're dealing with, the degree of the function is going to equal the number of solutions. But there's going to be some times where you have a repeated solution where, say like a repeated solution, like where it's basically x equals 2 times. That's technically one solution, x equals 2, but it's a repeated solution. So, and I say almost for this, but essentially, whenever your degree is there, 3, that is, I would say, the most amount of solutions you can have. You can't have any more than those 3 solutions right there, all right? You can have 3 solutions, maybe 2 solutions, but you can't have 4 solutions for this, all right? Okay, so moving on for this one here, all right? Finding all zeros by factoring. I take a look at this 4 right here, and from that I see that you can only have 4 solutions or less. I might be able to have 3 solutions, 2 or something like that, but I can't have 5, all right? Can't have 5 or more solutions, all right? So now, let's go ahead and try and factor this, all right? See if we can find what these solutions are. So I got example 2 right here, x to the 4th power plus 2x to the 2nd power here. And with those exponents there, I see that 4 to the 4th power into the 2nd power, I basically see that this 4 right here is double of 2 right there, all right? 2 doubled is 4, all right? Now, to do the method that I'm going to show you, which basically is, treating this like, just a regular trinomial, this has to be doubled of that, all right? So, for example, like, x to the 6th and then x to the 3rd. 3 doubled is 6. X to the 8th, x to the 4th. 4 doubled is 8, all right? Now, because I can do that, because this is doubled, 2 is doubled than 4, I can do this. Say, for example, if instead of x to the 4th power, it was instead x to the 3rd power plus 2x squared minus 3, then we wouldn't do the method that I'm about to show you. Right? Then we wouldn't be able to do this method I'm going to show you. But because this 4th is double than 2, we can do this method here. All right. Let me go ahead and erase some of this stuff here and get this set up. So now what we're going to do is we're going to set this up, honestly, like a trinomial that we did in the past. All right, like a trinomial that we did with quadratics. So I set up this x here. All right. And then I have -3 on the top. So what I'm going to do is my c value and my a value, all right? I multiply my a, my c value. Well, my a value is 1. My c value is -3, so it's 1 times -3 is -3. And I put my b value down here, the 2. And then what I'm trying to do is I'm trying to find numbers that multiply to -3 and add to 2, all right? And if you look for those numbers, what you'll find is you actually will find two numbers, 3 and -1, all right? 3 times -1 is -3. 3 plus -1 is 2, all right? Now from that, what I'm going to do is I'm going to split apart this 2x here. I'm going to split that up right here and right here, all right? From that, I get x to the 4th power plus, and what I'm going to use is I'm going to use this 3 and this -1 with the x squared. So I'm going to split it apart as plus 3x squared minus 1x squared, which is also just the same as -x squared minus 3, and then equal to 0, and then we go from there, okay? All right, so then going from there, what we do is just like we did with the last one, we move this, we kind of split it up to where we have, you know, four terms. What we do now is we just group them together. And we're going to go ahead and solve by, and going to go ahead and factor them out. So factor out of this GCF right here, I get x squared, and then what I'm left with inside is x squared plus 3. Factor out of this one, I can take a -1 out. Again, if you have a first term is negative, you take the -1 out, and then from there, where you go is you have x squared plus 3. -3 divided by -1 is just positive 3 equals 0. All right. I have the same thing in these parentheses here, so I'm on the right track. So from here up to here, I can write out 2 parentheses now. Outside of my, combine the outside, combine the inside. The inside of my parentheses is just x squared plus 3. The outside of my parentheses, right here and right here, I combine those together just to get x squared minus 1 equals 0. All right. And then from there, what I do is I just go ahead and set these equal to 0. Set all these individual equations equal to 0. X squared minus 1 equals 0. And x squared plus 3 equals 0. All right. I'm going to add them both to each side. I get x squared equals 1. This one right here is just going to be x squared equals -3. I'm going to square root both sides. And just as I did in the last problem, if I square root this 1, square root of 1 is 1, but not just positive. It's going to be plus or minus 1, x plus or minus 1, all right? And then for this one right here, I'm going to square root the x squared, square root both sides, cancels out, cancels out. I get x equals, well, the square root of a negative number. All I do is I bring out an I, so it's just going to turn into I times the square root of 3. Now again, just like I did with this last one, I square root this. It turns into both a positive and a negative. Oops, excuse me. Turns both into a positive and a negative, all right? And then if I look, I have the exponent of 4 there. I have 1, we got two solutions here, 1, 2. This counts as 2 solutions here. I have 4 total solutions, which matches what my degree is, so I know that I am on the right track there, all right? All right, so there is one more example that I don't have enough time to go over in this video. I will go over this example, plus also probably another example of the same kind in the next chapter, or in the next video, so just keep a lookout for that. Thank you.